Hello, Matt G for IYT here. Today we're looking at the full license mock examination number 1, version 1.6, and we've reached question 26, which reads, the selectivity of a superheterodyne receiver is determined mainly by the A, IF amplifier, B, detector, C, audio amplifier, or D, frequency changer. So we're being asked about the selectivity of this superhet receiver, and let's flip over to the full license manual and remind ourselves about what that term means. So selectivity is quite often appears alongside the sensitivity. Let's take a quick look at that first, because it's related but different, and I often find myself confusing the two. The sensitivity is about the weakest signal that a receiver can receive while still giving you a useful output. So a more sensitive receiver will be able to receive and it will allow you to listen to much weaker signals, and they may be weaker, perhaps they're coming from further away, or they're weaker because they're being transmitted with lower power. And so sensitivity is about the level of amplification within that receiver, but there's also it also has to factor in the levels of noise coming from either outside of the receiver, so are we amplifying only things that we're interested in, and also are we not amplifying sources of noise that may come within the receiver, which is likely to have things operating on or very close to frequencies we might be interested in. So sensitivity is about about the weakest signals that you can hear. Now selectivity is about what the receiver can reject, and I'm not talking about rejecting things that we want to listen to. That will make for a very bad receiver, but it's about rejecting things that we're not trying to listen to. For example, I could be sat on the 20 meter band listening to some really rare DX coming in from the other side of the world, and if somebody then started calling CQ, say 5 or 6 kilohertz up from me, I want my radio to be able to reject I want my radio to be able to reject that person calling CQ and allow me to still hear what I'm listening to. So it's about rejecting other signals on adjacent channels, and a more selective receiver is going to be able to reject things to a higher degree that are closer to what you're trying to listen to, and so that would be things outside of the bandwidth of what you listen to. So say with a single sideband receiver, you might want to make sure that everything more than 3 kilohertz away from the frequency that you're on is completely rejected by the receiver and you don't hear it. So that's selectivity. Now the question is asking us about the parts of a superheterodyne receiver that is going to determine the selectivity, and superheterodyne, hopefully from the full license manual, is going to be a really familiar term because you're completely comfortable with the architecture of a superheterodyne receiver. But let's take a quick look at this one here, and this is a nice diagram in the receiver section of the full license manual. And the thing about the superheterodyne receiver is, unlike a TRF receiver where you tune effectively the whole receiver to the thing that you want to listen to, with a superhet receiver we are tuning just this initial part here. So we're using this local oscillator as an input to a mixer. That mixer is going to take our 145 meg input, is going to mix it with our local oscillator input, and in this case it's going to give us, with this local oscillator, 145 will get mixed down to 10.7 megs. We may want to listen then at a different frequency, so we would change our local oscillator. That would then mix down, say, 145 500, and that would mix it down to, again, to 10.7 megs. And the whole point with a superhet receiver is that it always mixes down to 10.7 megs, and that basically means that everything after this point is super optimized for 10.7 megs, the intermediate frequency. And we can see here we've got a couple of stages of IF intermediate frequency amplification. Then we've got our detector, so that's pulling our, the useful content out of the signal that we're hearing. In this case, it's probably audio, so going into this audio amplifier and then amplified and sent out through a loudspeaker. So what we have here is a system where everything after this point is optimized for a particular frequency. And that means our filters, our amplifiers, they can be super sensitive and super selective, bang on 10.7 megs, and rather than trying to move those very precise, sensitive, selective components around, we're changing what we're putting in to align to our super selective and super sensitive components. So the question is asking about which parts are going to determine the level of selectivity, and we can see here it's this first IF amplifier is the first thing which is hearing which is hearing that intermediate frequency that comes out of our mixing process. So it stands to reason that the selectivity of this IF amplifier is then going to impact everything else after it in that chain. It's going to a very unselective or an IF amplifier with poor selectivity is then going to mean that this one has to work harder and be even more selective. Likewise, maybe that could have an impact on the detector and everything after. It's this first IF amp in the chain which matters in this case. So let's come back to our answers, and well, we've pretty much answered it with that, haven't we? Because it is the first answer here is the IF amplifier. Well, we like to also look at the other answers as well for these questions. So could it be the detector which has an impact on that? Well, at this point, the detector is taking the intermediate frequency and then it's extracting the audio from that. So at this point, if we've got some poorly selective IF amplifiers, the detector is not really going to be able to make up for that. It's going to be trying to demodulate everything we're putting into audio, and it's probably going to come out with lots of noise on it. So it's not really the detector in this case. We can scrub that out. And for the same reason, because it comes after, it's also not the audio amplifier either. So let's get rid of that. I'm getting confused with my tabs. So let's get rid of the audio amplifier, and I didn't see anything on that diagram called the frequency changer, so we can scrub that out as well. So it makes sense, looking at the other answers, that it is in fact the IF amplifier which determines the selectivity of the superheterodyne receiver. Let's get down to the answers, see if we got that right, and we can see, of course, for questions 26, it is of course answer A. Thank you very much. I'll catch you for the next one.